So we now can take a look at some of the measuring tools. So we have, for example, a ruler, which just helps to measure the distance between 2 points on the mesh. So, for example, if I want to use these indents over here, I can mark one and the second and see the distance between them. But this is just a straight line. So what's the distance between these 2 points? What's the shortest distance? Okay, click on escape. We also have section tool, which is like the additional panel that we have here. So we can define section all by ourselves. So for example, if I want to cut this, split this in half, like in the middle, like this. So I can take a look inside and see how it looks. Plus I can select each of these segments and see some additional information over here. So it shows the length of the line, sort of perimeter, and the area. These are, of course, millimeters. I can also export this cut in SVG or DXF for using downstream applications. For example, in some CAD system, you don't really need to export the entire model. Sometimes you just need a few cuts, and then you can make sketches using this, using these outlines. You can, of course, change their position. There is a shift where you can just move it to the point where you need it. Okay, so I can also define a section by 3 points. So for example, pick 3 points. Let's say I pick one here, here, and here, and it's defined like this. And we can, of course, change the position of it once again. So if we have some flat area, which we want to use as a reference, it's a good idea to use the 3-point method. So for example, I can pick 1 point here, 1 point here, and 1 point over there. And then just move this section over here. And of course, once again, I can select any one of them and export them as SVG or DXF. And I see the parameters of here as length and area. Okay, so I can invert plane normal selection. So if the direction is not correct, I can always invert this just to flip the side which is hidden and which is shown. And I can, of course, cut this part or even cut it on source frame. So cut will just remove these parts that are now invisible from the result. And if I mark it cut source frames, it will also be removed. These respective points will be removed on the point clouds as well. For some cases, we may do a basement. So for example, if it's some kind of statue or something, so we can make a little basement for it, specify the number of sides for this basement, the height of this basement, and the radius. So I can just increase it, let's say 200 or more. So let's say like this, and it will be like a little pedestal on which this part is going to be, but that's not something we going to use this time. So I'm clicking cancel, and we get back to the mode. Another thing that we might be interested in is geodesics. It shows the distance between certain points on the surface. So it's not like a ruler where it shows like a direct line between 2 points, but it shows the line that connects 2 points on the surface. Before using this tool, it is better to simplify the model. So here we have 600,000 faces, which is enough, which is okay. And if I go to the geodesic distance, I can pick a source point, let's say here one on the top, and it shows this animation, which means that analysis is now underway. After analysis is done, you see that the object is segmented in those color stripes, which represent the distance from the source point. And we can, of course, pick a destination point, let's say over here, and it will show me the line that connects these 2 points. So the shortest path from this point to the second point looks like this. And we can also export it as DXF if we like, and use it in downstream applications. All right. Another thing that might be useful for comparing two results is as so-called distance map. So we have first part and the second part. In this case, they are pretty much similar. So let's maim this part a little bit. So let's say I'm going to cut this area from here and just fill the hole without any bridges or anything. So of course this hole wouldn't look as pretty as the original surface. So I'm just hole fill it like this, so you can see it's not how it was before. And let's say the same over here. Let's say I'll cut this little area from here and just fill it. I'll take this hole, fill it, and we have those sort of like flat part over here. So this is our part number 1, and there's part number 2 when we still have original shape. So if I want to compare them, I can select both of these results, first and second. They should be aligned. In this case, this is true because they're made of the same skins. And I'm going to distance map, and I can set source mesh and target mesh and click calculate. So it will now calculate and show us the color map of the distance where these parts are differ. And we can of course clamp distance and set the specific value that we want to zoom in and check. So you can see that there is quite a substantial difference really. So if I include maximum distance to the maximum deviation that we have here, so here is our color map. So it shows us that this part, the blue part, is basically the same on two models, but here we have like a difference, and it shows how much they differ. So here they will differ quite substantially, so it's like 8 millimeters, 8.5, and here in a red area it will be like 12 or something, so it's quite a big difference. And it can of course show target mesh, which just shows where this difference is, so you can see how it goes higher than this area over here, and it sort of hides here behind this bulge that was created. So it's useful to compare a couple of meshes, which can be used for inspection, for example. Okay.